Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So we're going to be looking at the last few questions from, this paper. So please make sure that you listen carefully, and I will emphasize certain points because I did notice that, from, the video that I uploaded a bit earlier, people were asking me to explain twice, do the explanations twice. So I'll basically re-emphasize certain points. But please note that obviously, I'm just explaining once so that, we avoid the video being a bit too long. Okay, so let's have a look at this question. It says a study was done to investigate the relationship between the head circumference and the nutritional status of some children under 2 years old. The box and whisker plots below show the head circumference percentiles of these children based on their nutritional status. Right? We are told that a total of 142 children were included in the study. Okay, 9.15% of those children, okay, were malnourished. So 9.15 of the 142 children were malnourished, and 129 children had normal nutritional status. Okay, so just to quickly analyze what's given to us here, we can basically say that, okay, to get the amount of learners or children, not learners, that were malnourished, what are we supposed to do? All that we're supposed to do is take that 9.15% of 142. That's going to give us the amount of children. Okay, so to get the children that were malnourished, we're going to just take 9.15% of the 142, and we already know how many children were looked at that had normal nutritional status, and it's 129 children. Okay, there was a greater representation of younger children with more than 50% between 1 and 8 months of age. Okay, here we're given the head circumference percentiles in normal and malnourished children under 2 years old, right? So here we're given the head circumference percentiles in the y-axis, and in the x-axis we've got the nutritional status of these children. This is for the normal children. This is the box and whisker diagram that was drawn for the normal children, and this is the box and whisker diagram that was drawn for the malnourished children. Okay, so now remember, when it comes to analyzing our box and whisker diagram, I'm just going to quickly explain this to you guys again, right? We know that our box and whisker diagram is divided into 4 equal parts, right? Okay, we know that. Okay, even if it's skewed, it's divided into 4 equal halves in terms of the percentages, right, that is represented by the quartiles. We know that from the first quartile, from the minimum value to quartile number 1, 25% of our data is represented. From Q1 to Q2, 25% of our data is represented. From Q2 to Q3, 25% of our data is represented. From Q3 to the maximum, 25% of our data is represented. This is Q1, this is Q2, this is Q3, this is the max, and this is the min. Okay, meaning that if we then had to now, determine the percentages that is represented by Q1, it's 25%, stays the same. Okay, then from the minimum to Q2, 50% of our data is represented. Okay, there. From our minimum to Q3, 75% of our data is represented in this region, and 100% from the minimum to the maximum. So we basically need to understand this, okay, before we have a look at, answering questions pertaining to these box and whisker diagrams, right? So then it says there, use the information and the box and whisker diagrams above to answer the questions that follow. Question 3.3.1. Write down the percentage of malnourished children with a head circumference that is below 33.5, below the 33.5 percentile. Okay, so here we want to determine what is the percentage of those malnourished children who had a head who have a head circumference that is below the 33.5 percentile. So we're going to basically look at the malnourished children. Then when you basically look at the 33.35 percentile, what do we know by that? We know that from the minimum value going all the way to Q3, how much is being represented in this region? It's 75% of our data, because this is just the minimum where I've basically indicated when we started that red line. Then you've got your Q1, then this is our Q2, then this is our Q3. Then from the minimum value to your Q3, it is 75% of our data that is basically represented there. 75%. Nice and easy. Question 3.3.2. Calculate the number of children that were below the median head circumference in the children with normal nutritional status. So here it's telling us that we need to focus on the normal box and whisker diagram. We want to determine how many children were below the median. So obviously, if they want to determine how many children were below the median, what do we know? From the minimum value to the median, what is the percentage of data that is represented there? We know that the percentage of data that is represented there is 50%. So for us to determine how many children were below this median, we know that it's 50% of the children or the normal children that were basically investigated. Okay, so how many were they? So we're just going to take question 3.3.2. 50% of the normal or the kids that had a normal nutritional status. So how many children were investigated that had a normal nutritional status? It is 129. So what do we need to do? It's going to be 50% of 100 and 129. So what is that? So 50% is 50 divided by 100, okay, multiplied by 129. How much do we get? 64.5. So that's the number of children that were below the median head circumference in the children with the normal nutritional status. Question 3.3.3. Now we need to basically comment. Comment on the selection of the sample of children selected. What can we basically, say about the sample of children that were selected? Okay, what can we basically see? We can basically see that they selected 9.15% of the 142 children were the malnourished. Okay, and then we found that 129 children that were sampled had a normal nutritional status. Okay, so now how can obviously we can't compare properly. We first need to change that 9.15% to an actual value. So what is 9.15 over 100 multiplied by 142? What is that? You get 12.993, which is approximately, like, maybe we can just say 13 children were selected. 13 children are selected that were malnourished. And we can also see that 129 children were selected that had a normal nutritional status. So what can we see here? Do we see that already, right? The sampling is unfair. Okay, it's unfair because you can see that there's already, based on the fact that there's more children that were selected that had a normal nutritional status compared to the children that were malnourished. Okay, it kind of makes the sample of the children unfair, biased. It favors the normal children. Okay, it favors the normal children. Okay, so obviously then we can't rely on an investigation that's done where the sampling is not fair. We've got 13 children, only 13 children were looked at that were malnourished. However, there were 129 children that were looked at that had a normal nutritional status. Okay, so then it's biased, it's unfair. Okay, it favors one side, which is the normal. Okay, so therefore, based on this, we can't obviously, basically rely on this data to make any kind of a conclusion. Okay, it's unfair sampling that we can see. It favors the children that have a normal nutritional status. So we can't obviously now make any valid conclusion based on this. Right? Cool stuff. So I hope that basically makes sense. The taker is us just remembering that obviously the different sections of our box and whisker diagram represent certain percentages. Okay, and if we basically understand that, then we are able to then answer the questions. Let's have a look at the next question. Question 4.1. So question 4.1 is us basically analyzing, this table that is given to us and answering questions pertaining to this table. It says that the Swartz family received news that their daughter was selected to go on a sports tour to Bloemfontein. They compared the in-store and online prices of two supermarkets for items needed to prepare meals for the bus tour, right? So obviously, the Swartz family daughter, has to go to Bloemfontein, right? So obviously they want to prepare some meals for her, so they want to go buy a few items from certain stores, right? And they want to basically compare how much would the prices be if they decide to go buy inside the store, or if they decide to go buy or to buy the items online, right? And then they're comparing, these two stores. So the below shows the in-store and the online prices of P&P store and W&W store for some items. Okay, so table 5 shows the price in rands of two stores in-store versus online prices. Okay, so these are the items that they basically want to buy: apples, bread, cabbage, Coca-Cola, eggs, cake flour, milli meal, margarine, milk, rice, sugar, tea. Obviously, they're not buying delivery. Okay, they're just saying, obviously, if they have to deliver these items, this is how much you would pay if you decide to buy it where online, right? So we basically have the P&P store prices here, the in-store price, the online price. Then we've got the W&W store, the in-store price, the online price. Okay, then we're gonna obviously use this table to help us answer questions that are given to us. Question 4.1.1 says write down the modal in-store price for P&P store. What is the modal or the mode? Okay, this word should sound familiar. If you want to determine the mode, we are just trying to say what is the price that occurs the most. So that's basically what we want to basically look out for, right? Where are we going to focus our attention? We're going to focus our attention on the P&P store, but where the in-store price. So we're going to just focus on the in-store price, and then we want to look and see, is there an amount that appears more than once? If there is an amount that appears more than once, that basically means that that is our modal in-store price. Okay, so if you basically go through all these values, you'll see that there is no amount that appears more than once. If we basically just go down this column, there is no price that appears more than once. So what can we conclude? We can basically conclude that there is no mode. Question 4.1.2. Determine the number of items where the in-store and online prices are the same for the W&W store. So now we are focusing our attention on the W&W store. W&W store. Okay. What do we want to see? We want to determine the number of items where the in-store and the online prices are the same. So where can we see that the in-store prices as well as the online prices are the same? So we basically need to obviously go down this list. So we're going to start there, not the same. not the same, they're the same, the same, the same. So it's 3, 4, 5, 6, 7. How many items, okay, are the same, have the same prices? Okay, it's basically 7 items. Question 4.1.3. A one-way trip to the PNP store is 15 rand. Okay, so if Mrs. Swartz just goes to the store, okay, it's 15 rand per person. Calculate how much Mrs. Swartz would be saving if she bought all the items listed in the table directly from the store rather than shopping online. Okay, so now if she decides that she wants to buy her items from the PNP store, okay, she decides that, you know what, I actually want to buy my items from the PNP store and I'm gonna actually go physically to the shop and go buy these items. How much would she actually save if she goes and buys at the store? So that basically means that we want to determine what is the amount that she's going to pay if she goes and she buys at the store. What would be the amount that she would pay if she buys it online? Okay, including transportation costs, and then we obviously want to then, get the difference to determine how much she would actually save. Okay, so that basically means for question 4.1.3, okay, we're going to start off by just determining how much you'd pay, right, if she goes in store. Okay, remember we're focusing on the PNP. So if she goes in store, how much would she actually pay, right? We're basically going to look at this here, the total for the goods or the items. If she buys in store, it's basically going to be the total that she will pay is going to be that 208 rand, comma 74, plus we obviously need to also include transportation costs. She is going to the store and she is coming back. Okay, so then to go it's 15 rand, to come back it's another 15 rand, so it's going to be 2 multiplied by 15 rand. So then the total that she would then spend if she decides to go buy in store, it's going to be 208.74 plus 2 times 15, and this is basically going to give us 238.74. So that's basically how much she would pay if she decides to buy in store. Now, how much would she pay if she decides to buy online? So if she decides to buy online, the total price that she would pay, remember for online, it also includes, the delivery. Okay, it's already included there as well, right? So the total for the online, it's just going to be equal to 261.80. Meaning now, right, how much would she save? Because we can already see that if she decides to buy in store, right, she's gonna pay less even when we include the transport costs. So how much would she save if she decides to buy in store? So therefore she would save how much? We're just going to take the 261.80, which is how much she was going to spend if she bought it online, minus 238.74, and that is equal to 261.80 minus 238.74. You will get that it's 23 rand, 06. So that is actually how much she would save if she actually decided to go buy, all these items in store. Question 4.1.4. Determine the median price of the listed items for in-store shopping in WW store, right? So here, very easy. We are just calculating the median, okay, for the in-store prices. So we are focusing our attention on the in-store prices, and we are just trying to get what would be the median. Remember, for us to get the median, we just need to make sure that we arrange all our prices in ascending order. Once we've arranged all our prices in ascending order, all that we can do then now, we can look for what is the middle value. Okay, so you can just check then here. We want to now arrange all these values that are given to us here in ascending order from the smallest value to the biggest value. So you can see that the smallest value is 11.95. I'm going to start with that value. And then the biggest value is 29.95. That will be my last value. So I'm just going to arrange all these values for you in ascending order, and then we are basically going to find the median. So it's going to be 11.95, then 12.99, 13.95, 14.99, 15.95, 15.95, 18.95, 20.99, 22.95, 23.99, 27.95, 29.95, right? So we've basically arranged all the data in ascending order. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can see that we've got an even data set. So that tells us that our median will be a value that's in between two values. Okay, so our median is going to be, so we're just going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our median is an amount that is going to a value that's in between these two values. Of course, we've got 6 on the left hand side, we've got 6 on the right hand side. So to get the median, it will be 15.95 plus 18.95 all over 2. Okay, and then what do we get? We will basically get that 15.95 plus 18.95 is 34.90. If you punch that into your calculator, divide that by 2, our answer is 17.45. So that is what the median price of the listed items there. Okay, last question, question 4.1.5. 4.1.5 is a probability question. They say calculate the probability of randomly selecting an item from P&P store where the in-store price is exactly the same as the online price. Remember, when we're calculating probability, probability is equal to favorable outcomes divided by total outcomes. What are the favorable outcomes? The favorable outcomes is what the question is asking you for. We want to determine the probability, right, that the in-store price will be exactly the same as the online price. That is what we want to look out for. What are the total outcomes? How many items do we have in the P&P store? So then we're just going to now look at, this here. We're going to look at the P&P store, right? Favorable outcome, we want to look out for the prices where they are exactly the same for the online and for the in-store. So we see that it's 1, where it's exactly the same, 2, exactly the same, 3, exactly the same, 4, exactly the same, 5, exactly the same, 6. So the favorable outcomes, okay, where we've got items where the in-store and the online values or prices are the same, it's 6 divided by total outcomes. How many items do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items, meaning that then the probability, if you simplify further, 6 goes into itself once, goes into 12 two times. Also, your calculator can just do that for you. So that's the probability. They were not specific on how we need to leave our answer, so we can just leave it as a fraction. If you want to leave it as a decimal 0.5, you can also basically do that. Okay, so we've basically answered the whole of question 4.1. Okay, I hope I managed to, clarify everything for you guys there. Let's have a look at question 4.2. So now, question 4.2, guys, right? It deals with income and expenses, right? Where we have to do a break-even analysis, right? Okay, break-even analysis. This is the concept that is being assessed here, right? So before I even have a look at the questions here, because I do know that I haven't really done, videos on, doing a break-even analysis on my list, on my YouTube channel, but I have done, lessons with my learners that take on, lessons with me, right? Okay, I'm gonna just give you just a brief overview of the formulas that you need to be able to work with when it comes to calculating in total income that a business is making, calculating the total costs of a business. All right. So please pay attention. I'm just going to write these formulas here because we are going to refer to them as we are basically going through these questions. Now, if you want to calculate the total cost that a business has, right, you say total costs is equal to the fixed costs plus variable costs. That is how we calculate the total cost of a business. So, what are the fixed costs of a business? Maybe renting a shop so that you can sell something. Those are the fixed costs. How do we calculate variable costs? To calculate variable costs, it's the number of items produced or sold multiplied by cost price. So this formula, it is very important, okay, when it comes to, obviously doing our break-even analysis, because sometimes it even comes in handy, right, where you have to now fill in missing values in a table where there's incomes, there's expenses, and you need to make use of this equation. Very, very important equation that we need to basically know. Another equation that is very important when it comes to, this concept, right, is calculating the total income for a business. So to calculate the total income that a business is making, it's basically going to be the number of items produced multiplied by selling price, how much you are selling your items for. Okay, so we need to basically have these equations at the back of our heads because they're going to be very important when it comes to analyzing this situation that is given to us here. It says that the Swartz family also decided to buy and resell donuts in packets of 4 in order to fund the tour. Okay, they sourced the prices of donuts at 4 stores. Okay, their target was to sell 100 packets of donuts. Then we are told that, right, the fixed cost of buying and repackaging of the donuts is 201. So in this case, we are already told what is the fixed cost. Okay, we know then in this scenario what is the fixed cost. The graph of the income and expenses for the buying, repackaging, and selling of the packets of donuts, as well as the store prices of the donuts, are given in Annexure C. So we're going to analyze Annexure C and the information above to answer the questions that follow. So let's have a look at what's happening here, right? So obviously we are given a picture, right? That's basically giving us, what is the cost price of, these donuts in these different shops. At the P&P store, it's 4 Rand 99. At the W&W store, it's 5 Rand 95. At the SPR store, it's 3 Rand 49. At the FLM store, it's 2 Rand 50. Right? And then we are given the income and expenses graph that we are basically going to use to probably do a break-even analysis, right? Basically do a graphical technique to help us determine where the business is making a profit or a loss. Okay, but before we even go back, let me just help you guys analyze this graph, right? We can see that where there's an intersection of your income and your expenses, we basically call this point what? The break-even point, okay? And at the break-even point, the income is equal to the expenses. So by looking at this graph, we basically see that at this region, okay, the business is making a profit. And at this region, okay, so if you sell less than 20 items, the business is basically working at a loss. Also, very important, right? This is just additional information. If the question is asking us, right, how many packs, right, of donuts must this business sell in order to make a profit? You will never say that, you shouldn't say that the business must sell 20 packets. No, right? It is advisable to always go a 1 unit higher. Okay, right? So in this case, the business must maybe sell 21 packets of donuts for the business to start making a profit. Yeah. Also, looking at the last part, how many bags of, or packets of donuts, okay, does the business, what can we basically determine is that the business will basically make a loss, right? The business will basically be working at a loss if it sells less than 19 bags. Okay, so we always need to go 1 unit less, 1 unit more to determine how many bags must be sold for the business to make a profit. Go 1 unit more than the break even point. Okay, for the business to make a loss, that basically means that how many bags are sold. Okay, 19 or less bags are sold. If 19 or less bags are sold, that means that the business is working at a loss. Okay, so now that we basically understand, what's happening in this graph, I think we can basically have a look at the questions there. Write down the name of the store that offers the third lowest price. So we're going to go to, these different stores that are given to us. Which store offers the first lowest? It's this one. It's the lowest, first lowest. Then the second lowest is this one, SPR. Then the third lowest is this one, PNP store. Okay, so the store that offers the third lowest price, question 4.2.1, is the PNP store. Question 2.2. The total cost of buying and repackaging 50 packets of donuts is 701 rands. Determine with calculations from which store they bought the donuts. So with this question, it requires us to now basically make use of these equations that are provided for you guys in the beginning, right? Okay, what do I mean by this? Okay, what do I mean by this, right? We are trying to determine what is the cost price. That's what we're trying to determine. Once we're able to determine the cost price, we will then be able to determine which store did the family buy their donuts or purchase their donuts from. Okay, right? So that's basically what we are trying to determine. So how can we basically go about getting that amount? For question 4.2.2, for us to determine the cost price, because we want to determine the store where they bought the donuts. So to determine the store where they bought the donuts, we want to determine the cost price there. Okay, we're trying to determine what would be the cost price. Okay, so for us to determine the cost price, we remember, right? Total cost is equal to fixed cost plus variable cost. What are the total costs in this context? They're telling us that the total cost for buying and repackaging 50 packets of donuts is 701 rand. So that means that they will put 701 rand is equal to, what are the fixed costs? Remember, we were told there, fixed costs for buying and repackaging is 201. 201 plus all that we need to determine here is the variable cost. Okay, and then remember, how do we determine the variable cost? I'm just going to write it there to help us determine the variable cost. Variable cost is equal to number of items produced multiplied by the cost price. So now we want to determine how many donuts were basically produced. So in this case, they're asking us what would be the total cost for buying and repackaging 50 packets of donuts. So to get the number of items that were produced, we're going to take 50 packets of donuts. But remember, we were told that each packet has 4 donuts. So that basically means that we are basically going to take that 50, we will multiply it by 4, multiply it by the cost price to get the variable cost. So what does this mean? 50 multiplied by 4 gives us 200, multiplied by the cost price is the variable cost. So this basically means that where I see variable cost, I'm just going to write there 200 multiplied by cost price, right? So let's just basically do that. Okay, so I'm just going to rewrite this there. The 701 is equal to 201 plus, remember, variable cost there, right? From there, we are going to take that 701 is equal to 201 plus, what is the variable cost? We said that it's 200 multiplied by CP, 200 multiplied by the cost price. CP is just as a cost price. Then what do we want to do now? We want to determine the cost price. We want to isolate CP. So we are just going to do our mathematical operations. We're going to take 701 minus 201 is equal to 200 multiplied by CP. Then we want to obviously isolate the CP. We're going to divide by 200. We're going to divide by 200, okay? And therefore, we will then get what is the CP, cost price. Okay, so 701 minus 201 divided by 200. I'm just doing it in one step. Then we will see that it's actually 2 Rand and 50 is then the cost price. CP is cost price. So we can then make a conclusion. Which store did they buy the donuts from? Which store has a cost price of 250? It is the FLM store. So they bought their donuts from the FLM store. All right. So therefore, they bought their donuts at FLM store. Nice and easy. But if you didn't know of this formula, you are not even going to have any cooking clue of how you were supposed to start off this solution. All right, cool stuff. Question 4.2.3. Mr. Swartz stated that the break-even point was reached before the sale of 20 packets. State with the reason whether you agree or disagree with his statement. Mr. Parker is saying that the break-even point was reached before, he's saying that it's reached before 20 packets. So that means he's saying that the break-even point is probably somewhere there, before 20, any value before 20. So do we agree with Mr. Parker? First of all, we are going to say we disagree with Mr. Parker. We cannot say that the break-even point was reached before 20 packets. Why are we saying that it cannot be reached before 20 packets? It's because we can see that before 20 packets, what is happening? The expenses are greater than the income. And we definitely know that at the break-even point, income is equal to expenses. So that is why we disagree with Mr. Swartz. Okay, so we're going to just say question 4.2.3. We're going to just do it here at the side. Question 4.2.3. We disagree with Mr. Parker because before 20 packets, the income or the expenses, the expenses are greater than the income. And we know that break-even point occurs when income is equal to expenses. Not when income is greater than expenses or when expenses are greater than income. When income is equal to expenses, that is when the break-even point occurs. Okay, so in this case, we are going to disagree with him because before 20 packets, the expenses is greater than income. So it cannot be the break-even point. Okay, so there it just needs you to first understand what is a break-even point. Okay, so if you don't even know what is a break-even point, you'll struggle to understand what's happening there. Okay, but if you just listen to what I've said attentively, you should be happy with that justification. Question 4.2.4. If the selling price increased, write down with a reason whether the break-even point would now be lower or higher. So here, you need to now practicalize this. They're saying that now, if you were to basically increase the selling price, we know from even this equation, if you increase the selling price of something, right? You increase the selling price, that means that you're going to increase the income that you will get. Simple as that. So that means that now, if you're looking at this graph, I'm going to make use of blue. If you're looking at this graph, now let's just focus on, the income graph. I'm going to highlight the income graph. Okay. I'm going to highlight the income graph. This is my income graph, right? If this selling price increases, that means that the income will also increase. So that means that the income will actually also increase here. So maybe instead of us having an income of 200, maybe it'll increase to maybe that amount, depending on whatever selling price. We are just generalizing. But whatever it is, we just know that selling price increases, income increase. So I'm just showing you what's happening graphically, né? So that means that this one, maybe the income is also going to increase. We are just changing the income graph because the income is increasing. So I'm just changing this brown graph and now incorporating like an increase in income. So 600, it's increasing income. Income is increasing. So that basically means that maybe if we're still starting at 0, but in this case, maybe the graph will look something like this. Okay, maybe I'm just trying to make it more understandable. Okay, let me just do it like this. So I'm just going to try to manipulate so that you guys see the point here. So maybe these are the new income points there. That's the other income point. It is increased there as well. That's another income point. New increase, right? So we've basically increased from the initial income, this green value, to this new income, right? Here, because we've increased the selling price. So it's a hypothetical situation. What are we noticing? Obviously, the expenses are not moving because they just told us about if the selling price increases, what would happen? So what do we see here? We see that if this selling price increases, what are we noticing about the break-even point? This is our new break-even point. Do you see that? We've got a new break-even point. But let's look at the previous break-even point. It was here. This was the previous break-even point. So what do we see? We see that if you increase the selling price, right, it increases definitely the income. And if it increases the income, what happens to the break-even point? It lowers the break-even point. Okay, it lowers the break-even point. Because now, if you're just comparing to our the initial break-even point was here, but because the selling price has increased, ultimately increasing the income, the break-even point now has lowered. So now to answer this question, if the selling price increase, write down as a reason whether the break-even point would now be lower or higher. The break-even point would be lower. Question 4.3.2 or 4.3.4. 4.2.4. Okay, 4.2.4. The break-even point will be lower. Okay, because why? Increase in the selling price increases income, therefore break-even point occurs sooner. And I helped you guys visualize what is being meant by that. Okay, I helped basically with that drawing there so that you guys can see what is meant when by that. Okay, I hope that one makes sense. Right, cool stuff. Now let's have a look at the last question. Question 4.2.5. Determine the percentage profits they would make if all 100 packets of donuts were sold. You may use this formula. So here, very easy. We just need to make use of our graph to help us answer this question, right? What would be the profit that they would make if all 100 packets of donuts were sold, right? So if they basically sold all 100 packets, what, right? We need to basically determine what would be the income they would make. So we see that the income that they would make, the expenses would be 1,201. What would be the income? 2,000. So we just want to substitute these values into this formula, right? So question number 4.2.5. We are just going to take that amount, percentage profit. It's equal to, what is the total income here? 2,000 if we're selling 100. So it's 2,000 Rand minus the expenses, 1,201 divided by total expenses, 1,201 multiplied by 100. If you punch this into your calculator, you'll basically get that the profit is 66.53%. Okay, and that's that for question number 4.2. Almost there, guys. Let's have a look at the last question, right? It says people take flights daily. People take flights daily, okay, either locally, nationally, or internationally. Table 6 below shows the average daily flights taken in the top 10 countries, the top 10 aircraft operators for 2022, and the percentage change from 2019. Some values have been omitted. Table 6 is the top 10 countries and aircraft operators, right? So here we are just seeing that, okay, when we're analyzing, we've given the top 10 countries here. This is the year 2022. What were the average daily flights that were taken, right? And then we were told that this is the percentage change, okay, from 2019, right? So then we see that, hey, from 2019 there was a decrease, okay, in 20%, decrease by 25%, decrease by 9%. We don't know what's happening there. Decrease by 12%. So when we see the negative, it basically means that the change from 2019, there's a decrease in the average daily flights that are being taken. Okay, same here. The aircraft operators, these are different aircraft operators. Then the average daily flights there is given to us. And then here, what is the percentage change from 2019? Obviously, when you see that positive, it means that there was an increase in the average daily flights. But if there's a negative, there's a decrease, right? So we're basically going to take note of that. So question 5.1.1 says, write down the aircraft operator whose average daily flights increased the most since 2019. So we're going to look at the aircraft operator, right, whose average daily flights increased the most. So let's basically have a look at there, the aircraft operator, where there was an increase, the highest increase there. So we're just going to look for what is the positive, the highest positive value. The highest positive value. That is what we want to look out for. So the highest positive value there, it's not positive 9, but it is positive 13. Okay, so that was the highest, that's the aircraft operator that had the highest increase, or that increased the most since 2019. And here they obviously don't want the percentage, but they want us to write down the aircraft operator. So for question 5.1.1, the aircraft operator is Wizz Air Group. Question 5.1.2, France operated 4,290 average daily flights in 2019. Determine the missing value A rounded to the nearest whole number, right? So here we are trying to determine what is the percentage increase or decrease, okay? But if they're telling us that, France operated 4,290 average daily flights in 2019, but in 2022, we can see that France operated 3,763, we can see that there's a decrease in the average daily flights that are being taken there. So that basically means that for us to calculate that percentage, we need to think of calculating percentage increase, percentage decrease. How do we calculate, in this case, percentage decrease? Okay, we are just going to take question 5.1.2, the percentage decrease. How do you calculate that? Because it is a decrease in percentage, because the average daily flights have decreased from 4,000 to 3,000. It'll be the new value minus old value divided by old value multiplied by 100. So these formulas, we need to know them off by heart. So what's the new value? It's the current value for 2022, 3,000, okay, 3,763 minus 4,290 divided by old value 4,290 multiplied by 100. So what do we get there? It's going to be 3,763 minus 420 divided by 4290 times by 100. You'll get that it is negative 12.28. So that value A there, right, is actually negative 12.28. Okay, but remember, they actually said that we need to round it off to the nearest whole number, so it's approximately equal to negative 12. Okay, because this is a 2, that means that it doesn't change this value, it just stays as a 2. Good. Question 5.1.3. Calculate the range for the percentage change from 2019 for the aircraft operators. So here we just want to calculate what? The range, right? How do we calculate the range? The range is equal to maximum value minus the minimum value, right? So what's the maximum value minus the minimum value? But then we are basically told that here we need to focus on the percentages. So we're just going to be looking at the percentages here, right? So what's the maximum value here? Remember, the maximum is the highest value. Okay, so what is the highest value? It's that positive 13. Positive 13 is the highest value. Okay, minus, what is the lowest value there? Okay, negative 35 is the lowest value. It's a negative 35. So it's negative 35. Therefore, okay, if you basically take that, it's going to be 13 minus 35. What do you get as your answer? The range is 48, but remember, it must be percentage. Good. Question 4.1. Question 5.1.4 says calculate the missing value B. Right. If the mean number of flights for aircraft operators is 1028.2. So remember here, we just need to know, how do we calculate the mean? Okay, how do we calculate the mean? We know that mean is equal to the sum of all of those average daily flights divided by the total number of, values that we have there. Okay, so we're just going to use that. So question 5.1.4, mean, sum of all the values divided by number of values that you have in. So we are told here that the mean is 1028.2 equals to. Now we want to sum up all these values. So it's going to be 2,566 plus 1,347 plus 1,249 plus this, plus that, plus this, plus that, plus B, plus this, plus that, divided by how many values do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when you basically sum up all of those values, okay, you need to show this. It's going to be 2, 5, 6, 6 plus 1, 3, 4, 7. Sum up all those values. Okay, I'm not going to write it all down, but I think you get my point. So when you sum up all those values, you need to get 9,640 plus B, because we can't obviously sum this up, divided by 10. Then all that we want to do now, we want to solve for B. So we're going to do the inverse, multiply by 10 to get rid of the 10 on the right hand side. Multiply by 10. So 10 multiplied by 1028.2, you get 10282, which is equal to 9640 plus B. Then from there, we're going to take this 9,000, goes to the other side. So it's going to be 10282 minus 9640 is equal to B. So our B is 10282 minus 9640, it's basically 642 is equal to our B. Done. Last one, calculate the probability as a decimal. I'm going to do it here on the side. Of selecting an aircraft operator whose average daily flight increased from 2019 to 2020. So we're going to look at what? The aircraft operators, and we want to look for the aircraft operators that had an increase. Okay, so remember all the time when you're calculating probability, start off there. Question 5.1.5, probability is equal to favorable outcomes divided by total outcomes. What are the favorable outcomes? What we want, okay? An aircraft operator whose daily flights increase. So we're going to count where there's a positive there, because where there's a positive, it's just indicating that there's an increase. Divided by, what are the total outcomes? We just have 10 there. So divided by 10. So let's just count in where there's a positive. It's 1, it's 2, it's just 2. So it's 2 over 10, and then they want it as a decimal. So as a decimal, it's going to be 0.2. Then that's basically done. Okay, so done. Okay, so we've basically completed our question 5.1.5. Right, now let's have a look at the last one, exchange rates. When it comes to these exchange rates questions, listen to me very carefully. Listen to me very carefully. Okay, I'm trying to be, very quick and detailed at the same time. Okay, because I also didn't have time to record during the week. Okay, it gets hectic, guys. It gets hectic. But I tried. Okay, I tried. Timothy will fly from the United States of America to Palestine to play in a tournament. Before he leaves, he wants to exchange $2,580 for the new Israeli shekel. The currency used in Palestine is the new Israeli shekel. Okay. Now, what is meant here? What is happening in this table? What is this? If they say units per NIS, how can I interpret this? How can I understand that? It basically says, because these are the units divided by 1 NIS. So in other words, it basically means that for 9,322,3,584 divided by, because it's per 1 NIS. That's what is meant there. Meaning, if we had to now change this rate into an equation, it just means 1 NIS is equal to 9.3223584 Thai baht. Let's look at the next one again. What is meant by that? Again, it's 0. Let's look at the other one. 0.19368367 jot per 1 NIS. So if we had to change this rate into an equation, it just means 1 NIS is equal to 0.19368367 jot. Right? So that is what is meant there. That is how we can basically convert the units per 1 NIS into an equation that we can use to help us convert. Even here, now here it's NIS per unit. So it means that the NIS is the one at the top. So that means that this value that's in this column, it represents the NIS. So it's 0.107269 NIS per 1 Thai baht or 1 B, that B there, right? So it's just still the same thing again, right? It basically means that 5.16306 NIS per means divide by 1 jot, meaning that we can just write this as 1 baht is equal to 0.107269 NIS, meaning that we can write it as 1 George gives us, 5.16306 NIS. Okay, that is what's happening there. Okay, I hope this makes sense. Now, question 5.2.1. State whether the new Israeli shekel is stronger or weaker than the South African rand. So here we want to be able to determine if I have one NIS, how many rands will I get? If I have 1 rand, how many NIS will I get? And then we will be able to make a conclusion from there. Okay, so let's see, because we want to determine which one is the stronger one, right? So then let's see here, NIS per. So let's just say units per. So then here I can say that if I've got, remember you said that this basically means that, okay, I'm just going to write it again. This basically means that 5.0428413 rands per 1 NIS. So what does this mean? It basically means that if you've got 1 NIS, it is going to give us 5 rand and 0.428413. Good. Now all that we want to determine is that if now I've got 1 rand, how many NIS will I get? So now I'm going to look at this one. NIS per unit. What does this mean? I've got 0.198301 NIS divided by per, okay, per 1 rand. Meaning that if I've got 1 rand, I've got 0.198301 NIS. So now, which currency is okay? Is the new Israeli shekel stronger or weaker? We can see that it is actually stronger. It is stronger because you can just see that with just 1, I get 5 rand. But with 1 rand, I get 0.19. So we can just confirm that the new Israeli, question 5.2.1, it is stronger. Question 5.2.2. Calculate the amount Timothy will receive in new Israeli shekel, right? So all that we want to do in this case, we want to convert these dollars into NIS. So then here, we just need to go to the one that talks about dollars and NIS. So we can see that it is this one. So we can basically make use of that. Please note, even if you make use of this, it's the same thing, right? So remember, it basically means that, I'm going to write it again. I'm just trying to write this as like a rate. Remember, it just means that 0.27317867 US dollars per 1 NIS. So from here, I can write this as a equation. What do I mean by this? 1 NIS is equal to 0.27317867 dollars. I'm just putting the dollar here at the end. Okay, so that means that now we're going to use this equation, right, to help us convert those dollars into NIS. Even if you worked with this part there, that the 3.66061 NIS is equal to $1. You can even write it like this. Or, okay, remember, you can write it as, looking at this one, you can write 3.66061 NIS per $1 per unit. Okay, and then that just means that $1 is equal to 3.66061 NIS. So you can use either one of these equations, potato. It's the same thing, right? So then let's convert. We're going to just convert these dollars. So it is 2,580 multiplied by what we want. We want what? NIS. Okay, so it's 3.66061 NIS divided by what you have, $1. Get your answer, and we are Done. So it's 2580 multiplied by 3.66061 over 1. Answer is equal to dollars and dollars cancel. NIS 9444.37. And that is it. That is it. So I tried my level best to, be as quick as possible when it comes to this paper. But what's important is that we get the main points. I hope you guys enjoyed, these lessons with me, right? I'm going to upload paper 2 in time, right? So paper 2 will be uploaded as a whole paper, right? Latest by Saturday. So please make sure that you engage with then that paper as well, just how you guys engaged with paper 1. Thank you so much, guys, and I'll see you guys on my next upload. All the best with your exam tomorrow. You've got this. Calm down, right? As long as you've accumulated all the knowledge, all that you can do now is just apply it, okay, in your exam. Do not panic, because if you panic, then you'll make silly mistakes. Okay, all the best, guys. Much love, and I'll see you guys on my next upload.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.